1 times x what? Plus 3. Go, 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 go! What are my critical numbers? Faster, faster, make the sign line, orale. Test the values, come on. While you're writing the sign line, you're testing it out of your head.
I know, I'm already getting there.
You should be plugging in -5 already in there.
-5.
Good, good. Did you catch up?
Absolutely not.
I know.
Alright, so plug in -5. Let's go, let's go. -5 plus 1, negative. -5 plus 3, negative. Oh my god! Alright. Pick something between -3 and -1. -2. Alright, -2 plus 1, negative. -2 plus 3. Negative times positive? Positive. Very good. Alright, pick something on the other side of -1.
0.
0 plus 1, positive. 0 plus 3, positive. Positive, the negative. Very good. Alright, so what do we end up with? Negative, increasing, decreasing. So what do I have at -3? A min. At -1? Max. They weren't asking for that, but they're probably going to ask it in the next question. So we already have it. Alright, anyway, so f of x is what? Increasing on -3 to -1 because?
Because f prime of x is
Beautiful. F of x is decreasing on
Negative infinity, -3, -1, infinity.
beautiful. Because
F of x is less than 0.
f prime of x is less than 0. Determine the coordinates of the relative extrema of f and justify your answers. So now they don't want just the x part of the relative max or min. They want the what? The coordinates. That means the x and the y. So how do I do that? So where do I have my relative min?
-3.
We know the x is -3. What's the y? Plug it in where? The original. So we're looking for f of -3. So that means we want to know negative parentheses -3 cubed minus 6 times -3 squared minus 9 times -3 plus 2. Let's see if we can do that. That's probably harder than the calculus we did up there. What's -3 to the third?
27.
-27 times negative positive 27. -3 squared? 9 times -6?
54.
-54. 27 minus 54?
-27.
-27. -9 times -3?
Plus 27.
Positive 27. So -27 plus 27?
Zero.
0 plus 2?
2.
2. Oh, how fun.
Easy math.
That's why I was
Number
Oh, yeah.
16.
Relative max. What's the x value that we already know? -1. If we need the y, we need to plug it in. F of -1. So negative parentheses, -1 to the third, minus 6 times -1 to the second, minus 9 times -1 plus 2. Good?
Yeah.
Are we good? You need a calculator? Just say no, okay, like drugs. Right? -1 to the third. -1 times negative? Positive 1. -1 squared. 1 times -6? 1 minus 6? -5. -9 times -1? 9. -5 plus 9? 4 plus 2?
6.
Woo! You did it!
Twice.
It was just with -1.
Huh?
It was just with -1 we were having trouble.
For -1 you were having trouble?
The
Well,
negative.
he was having
Yeah, it always gets the kids. Okay, what would be the justification for the min and the max? We kind of ran out of space, so we'll just say it. How do I know I have a relative min?
Because the derivative.
Because f prime of x changes from negative to positive. How do I know I have a max? F prime of x changes from
Positive to
positive
negative.
to negative. That's using the first derivative. If I wanted to use the original function, I would have to say decreasing to increasing or increasing to decreasing. Both of them would be correct statements. All right, anyways, let's go. We're running out of time. We only got 30 minutes. So we have this graph. Okay, and it's graphed from -4 all the way to what? 14? No,
One.
from -4 to 1, right?
How to say
Okay.
what?
The first problem says identify the absolute max on the closed interval -4 to -1. So what would you call the absolute maximums there? What are we gonna write? Points, x's, y's? Points, very good. So what would be the points?
-4, 6, and -1, 6.
-4, 6. Okay, this one up here?
Yeah.
And which other one?
-1, 6.
-1, 6. Oh, okay, so this one and this one are the absolute maximums? Okay, cool. How about which ones are the absolute minimums?
How about A?
1, -14.
1, -14? Okay. This one way down here? Yeah, that's the lowest one, right, Papa?
Isn't it negative?
Wait,
Wait.
It's
It's -3 too?
Oh.
You sure? That's a relative min.
Oh, that's -1. I didn't even see
No,
that.
but it's.
Yeah.
He wrote
So
it
which
down.
one is it?
He wrote it down.
Why is it not 1 and -14?
Because the interval did not include, I looked at it, I was like.
Very good, because the interval only goes up to what?
Okay, right.
It only goes up to what, guys?
Some about that's
-1, somebody got punked. Okay, that's just teaching you to be careful, okay?
Oh.
Pay attention to the domain, to the restriction there. Alright, now absolute max. Now it's from -4 to all the way to 1.
That's the same.
So are the absolute maximums the same here?
Yeah.
Yes. So here would be -4 and 6, and the other one was -1 and 6.
Hey, look, now it's -1.
Now which one is the absolute min on this
1,
interval?
-14.
1, -14. Very good. Okay? That's what all this is, explorations, learning experiences, okay? It's okay to make mistakes, you gotta learn from them, okay, Anthony? Stop Snapchatting people, okay? Good? Huh? All right. You got confused, you gotta stay cool. So that was a graphical exploration of finding absolute maximums and minimums. We're gonna do an analytical exploration using algebra, using what we know, to actually prove and show that those values that we found were the absolute max and minimums in those particular intervals. Okay, because that's the way it'll be on the AP test. They might give you a graph, but that would be too easy. So they're gonna give you the equation and you're gonna have to work it out by hand. Okay, so notice it says, use the extreme value theorem to locate the absolute extrema. So what do they want me to give? Coordinates, x's, y's. Coordinates, okay? Here I want the points, all right? I want the x and I want the y. How do I know that it only asks for the y's? What would it say?
Yeah, your values, your f of x.
I heard somebody say it starts with a V. The values, right? So if it said find the absolute extreme values, then that would be only asking for the y's, okay? What if it said find the x values where I have absolute extrema? Then it only wants the x's, right? That's pretty straightforward. Okay, cool. So, of this function, which is the same one we did on the given closed intervals, which were the same two intervals we did, use your algebraic results to concur with the graphical conclusions from the previous page. Okay, so first thing is that it must be continuous. Is it continuous on those two intervals? Yes, because this is a what? Polynomial. Second thing we need to look for is where I could have absolute extreme values. Where are the two places that they could occur? Endpoints or at critical numbers. Okay? So did we already find the critical numbers? We did? Where do we find the critical numbers? All the way back here, right? We already found the first derivative and we found the critical numbers. So can I jump straight and just copy all this right here? Yeah? Alright, I'm going to jump straight to this part. Where I did f prime of x equals -3 times x plus 1 times x plus 3. So we're going to pretend we already found the derivative, I factored it, then we set it equal to 0, and we find out that the critical numbers are -1 and what? -3. So now how do I see which one's the absolute max and which one's the absolute min? What do you think I have to do with those numbers to figure that out? A sign line? No, that would be for relative maximum. Very good, okay, I have to what?
Good job, bro.
Test my critical numbers and which other ones? And the endpoints in who?
The original function.
The original function. Okay, because that's where I'm going to have maximums and minimums on the original graph. So I need to get these numbers plus the endpoints and test them. So I'll be nice and I'll let you use your calculator. So we're going to find f of what? What's the first endpoint? -4. I'm also going to look for f of, what's the next number in between them?
-1.
-3. And I'm also going to test f of what?
Negative.
Do you think I would test a critical number if it wasn't in the interval? Let's say I got a critical number and it was 5. Would I test 5? Why not?
It doesn't fall.
It's not in the interval, so that's another thing to keep in mind, okay? If the numbers you're testing are not in the interval, don't even test them. Good? Plug them in, see what we get. I'll let you use your calculator. What should we get when I plug in -4? 6. Right, because that's the point on the graph.
Yes.
Type it in, I want you to physically type it in and get a 6. All the time. So what you're gonna have to do? What are we plugging them into? Original function. What's the original function? That guy up here.
Can you please move your
So, did we truly get a 6 here? What should we get when I plug in -3? A 2. And what should I get when I plug in a -1? A 6. So how can I tell by looking at those y values which one's the maximum and which one's the absolute minimum? Which one would be the maximum then? The ones that got what? The ones that have 6, right? Because those are the biggest y values. Which one's the minimum? Which one's the smallest one? 2. We should have an absolute max at -4, 6, and -1, 6. And we should have an absolute min at what? -3, 2. So I guess if we would have done it like this, Pablo, we wouldn't have picked 1, -14, right?
Yeah.
Because we would have made sure that we only tested in that particular interval. Are you with me? You get the procedure to figure this out? Find the derivative so you can find your critical numbers. You're going to test your critical numbers and your endpoints as long as they fit within the interval in the original function. That's the part that messes kids up. Some kids do this and then they test them where? The first derivative. What am I going to get if I put in my critical numbers in my first derivative? You're going to get 0, so you know you're messing up. You're doing something wrong. Okay, so be very careful. Test in your original function. Good? You could say f of x is continuous because it's a polynomial. On other ones, you're going to say that they are not continuous, therefore you cannot guarantee like an absolute max or minimum. You could say because of the theorem. Mean value theorem does not apply because f of x is not continuous at this value, which is in the given interval. Cool? Alright, so for the second one, same procedure, right? We find the first derivative. We find our critical numbers. And we test them. Test critical numbers and endpoints. So here we're going to find f of -4 f of negative 3, right? F of negative 1, but we're also going to do f of who? 1, which is the second end. Make sure that you're checking them off, that you're using all of them. What were the first three? You already found them, right?
I just got it.
6, 2, 6.
Last one 14.
And what should the last one be?
14.
Negative 14. So now you just look at the numbers, which is the biggest one? 6. So that means that that's an absolute what? Absolute max. Absolute max. And which one's the smallest one?
Negative 14.
That's my absolute. Papitas? Do they match what we got on the other side with the graphs? For those intervals? They should. Super easy? Yeah? Can you take more or no? No? It's the oxygen.
Oh, yeah.
Alright, so what I want to do now is I want you to look at some questions to determine whether the extreme value theorem